On to the next section B question. We're looking at Leisure Co. Once again, I'll take the approach I took before, looking at the requirements before I read the stem to identify firstly outliers and secondly to prime myself ready to know what I'm searching for when I do come to read this. If Leisure Co aims to select the alternative that has the highest return under the worst case scenario, what should the room rate per night be? We're definitely going to need to reference the stem there. If they apply min-max regret rule, what should the room rate per night be? We'll definitely need the information on the left, and we'll probably have to build a regret table. Which two of the following statements would justify use of expected value for Leisure Co's pricing decision? This is an outlier, probably because it's testing our knowledge of when the expected value is an appropriate decision-making tool. Leisure Co is exploring the use of EV in aiding its pricing decision. So we need to choose two of these. Firstly, when weather conditions are full of uncertainty. That's not when we use EV. For EV, we need to have events that occur again and again, and the probability of each outcome is known with certainty. When the decision maker is an optimist and a risk seeker, that's not the EV person. This is a maxi-max person. EV tend to be risk neutral. When the forecasted weather conditions have remained similar for the past decades, that goes back to what I said for the first one, that predictability and able to apply probability to each outcome. When likelihood of each weather condition is known with certainty, again, that one is true. What's the maximum amount that Leisure will be willing to pay for such information? That's a perfect information question, so that's very likely to need information on the left. Indicate by clicking on the boxes whether each of the statements regarding decision-making techniques under risk and uncertainty is correct or incorrect. This looks like an outlier to me. By applying appropriate tools and techniques, senior managers can eliminate risk and uncertainty in decision making. We can manage risk and uncertainty, but we can't eliminate it. When a decision tree is used to determine the optimal course of action based on ranges of uncertain information, it reflects the risk of a neutral attitude of the decision maker. That's correct. So decision tree uses expected values, which is a risk neutral decision making attitude. So in this section B, we've got two outliers. And once again, if you pause the video, have a read through, and then we'll start answering the other three questions in this one. The question is, if they're aiming to seek the highest return under the worst case scenario, what is the room rate per night? That's the maxi-min decision rule. And the way we do that is we work from the right to the left. So maxi-min, so we find the minimum, and the minimum is the worst outcome based on the decision they can make. The only decision they can make is how much they charge per room, which is these three lines here. They can't choose demand, they can't choose occupancy rate, they can't choose probability. Make sure when you are building a payoff table, you build it so the decision they make is sitting along the top here. And then the question we need to ask ourselves, if room rates were 100 per night, what's the worst possible outcome? And it's this one here, 236. If they were 200 a night, what's the worst outcome? It's 242. If they were 350 a night, what's the worst outcome? 223. And then, as I said, working from right to left on maxi-min, these are the minimums along the bottom, and then we choose the maximum of them, which is 242. Now don't put 242 in here. Again, they can't choose which of the outcomes occurs. All they can choose is the rate, and then the demand will decide which of these actually occurs. And the room rate we would choose therefore is $200 per night. If they applied min-max regret, what should the room rate be? Again, we work from right to left. We start with regret, build in a regret table, then we find the maximum, and then we find the minimum. So the regret table looks a bit like what we've got on the left. So I'm going to put the occupancy levels in. It's worth practicing building tables in the scratch pad, because it's not very helpful the way it works. Because you can't tab, you have to use spaces and things like that. Keep it simple. Don't put too much in, like I'm not putting my $sign in or anything like that. And when we're building a regret table, what we do is we take each of the four things here, so super, peak, high, moderate and low, and we identify which is the best of each of those. And the min-max regret rule is almost like an opportunity cost rule. So looking at super peak, the best outcome is this 1575, and in order to get that, we'd have to have chosen 350. Had it been the case that we'd chosen 350, then we'd have no regret because we'd have not missed out. So this becomes a 0. no regret here. And then we compare this 1575 to the other two outcomes. So had we chosen 200 and demand was super peak, this is our revenue, so our regret is the difference between this cell and this cell. And then similarly, if we're chosen 100, our regret is the difference between this cell and this cell. And then we have our first line of our regret here, with this being the biggest regret, this being no regret, and this being in the middle. And then we do the same for the next level. So if we had high demand, the best outcome would be this one on the right, and then we find the difference between that one, and then the difference between that one and that one. For moderate demand, the preference would be to have 200 night, because that gives us 621, so there'd be no regret had we chosen 200. So this time it's the difference between this one, and the difference between this one and this one. And then finally, with low demand, 242 is the highest, so that's our no regret position, and then we compare to the other two. So this is our regret table. That's the first bit here. Now we need to find the maximum, and the maximum, I've probably confused you because I've used minus on some. Let's take that out. They're all negative or 0. So the maximum here, if we had chosen 100 as the rate, our maximum regret would be 873. Had we chosen 200, our maximum regret would be 473. Had we chosen 350, our maximum regret would be 59. And then we do the last step, which is minimizing the maximums. Well, this is the minimum out of the 3 I've highlighted, so 59, which means the room rate is, read from the top of the table, 350. In question 24, what's the maximum amount they should be willing to pay for such information? A private meteorological bureau claims to be able to provide an accurate weather forecast at least 1 year in advance, has approached them to provide such a service. How much should they pay? In terms of use of time, you might be better at guessing this one, particularly if you're running out of time on this question. There's quite a few steps to the calculations for finding what's called the value of perfect information. What we need to do is find the expected value without that information. Then we find the expected value with information, and the difference between the two is the maximum we'd be willing to pay. If you were running out of time and had to guess, I'd probably be guided a bit by this. You see, 714,000 is more than the revenue they would earn under 8 of the scenarios. So that's probably a bit high. The 291,000 is more than they'd earn under 3 of the scenarios. I think I'd be erring more towards one of the smaller values. Let's go through the actual steps and do the calculation. This is probably when it will pay off having practiced using the calculator, because to find the expected value for the $100 night, we multiply the probability, the 0.1, by the 702, and then we add to that the 0.3 multiplied by the 476, we add to that the 0.35 multiplied by the 358, and we add to that the 0.25 multiplied by the 236. And then for the $200 night, we do the same for this column, and for the 350, we do the same for this column. You can be a bit more efficient than doing everything, and it's often worth trying to save a bit of time. And here's what I mean by that. If we look at every value for the $100 room, or every revenue for the $100 room, and we compare to the 200, in every case the 200 is higher. So if I multiply 0.1 by 702, 0.3 by that, 0.35 by that, and 0.25 by that, and then I compare with the 0.1 multiplied by the middle columns, the 0.3, 0.35, 0.25, the expected value here will definitely be higher than the expected value here. Mathematically, it's impossible for this to be higher. So I'm not going to do the $100 because it's a waste of my time. Because what I'm going to find is one expected value for each room rate, and the highest is the one we would choose. So we're not going to do the $100 just to save some time. Here, this is higher, this is higher, this is lower, and this is lower when we look at the 350 compared to the 200. And sometimes you can eliminate another one, but it depends on the probabilities. So let's say these probabilities were different. Let's say this was 0.5, this was 0.4, and this was 0.05, 0.05. Again, mathematically, I can see quite quickly that then this would be the highest EV. But because of the way that this is profiled, I'm not able to do that. So let's go ahead and do the 200 calculation. So you see, using brackets, I've put all of the 4 steps of the calculation in here, multiplying each probability by the revenue, so the expected value here, is 63675. And now I just have to do the same, but for the 350. And this one is 68895. And as a decision rule, we would always choose the highest EV. So that means we would choose 350 a night because it gives 68895. Now we need to find the expected value, but with this information, this accurate information. Once again, I'm going to use a little table. I probably wouldn't do this in the exam, but this is just to demonstrate the steps. And you need to forget this process, I think, in order to engage with how this process works, because it's easy to confuse the two. They are both using probabilities, but in a different way. We've just seen how expected value works. But what would happen if we could have an accurate prediction? So if weather predicts demand, if we knew that the weather was such that we were going to get super peak, what would we do? We'd charge $350 a room because we get the highest amount. However, even though we can forecast it, we can't change it. So the likelihood of that occurring is 0.1. So over a year, 10% of the time, we would be charging this amount of money. Similarly, if we knew that the weather was such that demand would be high, which would we choose? We'd also charge $350 because that's given us the highest amount there. So our revenue would be $930, but because we can't control the weather, that would occur 30% of the time. When the forecast tells us to expect moderate demand, we're going to price at $200 a room. So that means our revenue is $621, and that will occur 35% of the time. And finally, when it tells us that demand is low, we're also going to charge $200 a night, and we're going to get $242. And following the same pattern, that will occur 25% of the time. So now my calculation is using the table I've created on the right. So 0.1 times 1575, 0.3 times the 930, 0.35 times the 621, and the 0.25 times 242. And that gives an expected value of 714.35. Remember, we're in thousands. That's that distractor. So that's how that got in there. Now the amount we are willing to pay is up to the difference between these. So we subtract the 688.95 is 25.40, which is that one there. That's the end of Leisure Co. Thanks for listening.